Welcome everyone to our Solar and Storage for Homeowners webinar tonight. My name is Alexis Miller and I'm super excited to have you here with us tonight. We're going to give folks about 30 seconds to get logged in and then we will get started. Feel free to drop into the chat where you're joining us from and your name. We're excited to have so many folks here with us tonight. Awesome. It's great to see people from everywhere all over the nation. I'm seeing Colorado to Oregon, Texas, Arizona. So we will get started here. I'm sure we'll have more folks dropping in as we get going. Again, my name's Alexis Miller. I'm the Director of Community Impact at Solar United Neighbors, and I'm located in Phoenix, Arizona. I'll start off with chatting a little bit about our logistics before we kick it over to our presenter, Corey. Corey, can you switch the slide for me? Great, so just a few logistics. I'm sure we've all been on a lot of webinars at this point, but just some reminders for folks. We are going to do Q&A at the end of the presentation. So we'd ask that you put all of your questions into the Q&A. If you go to your bottom control panel, you'll be able to see Q&A and chat. So we'd like to use the Q&A portion for all questions that you have and use the chat for having conversations with other attendees and comments. That just helps us to keep things organized. And as a reminder for folks, we will send out an email with a recording of this, as well as all the materials that we share. So don't worry about taking notes on everything. We will share everything with you afterwards. And with that, we will get started. I'll turn it over to Corey. Again, thank you all for joining us tonight.
Thanks, Alexis, and welcome everyone. I'd love to see that counter tick upwards, 300 some odd people who have joined us this evening. So thanks for taking some time out of your evenings to join us. As Alexis said, I'm Corey Ramsden. I'm the head of our Go Solar programs team here at Solar United Neighbors. Live in Washington, D.C. and have been a solar owner since 2012. And just wanted to point out some of the things that I'm so excited about. I don't have storage yet, would love it at some point in the future. And just want to reinforce how much really interesting stuff is happening in this space right now. We won't have time to get to all the really cool stuff in this hour, but we are going to cover some really useful information. And we hope you think at the end that this time was well spent. So thanks again for joining us, and let's get started. First of all, we just want to make sure that we have, like I said, 300, almost 400 people on this webinar. We're going to start with some basics because we want to make sure that everybody's on the same page about the technology and about how it works. So you might hear me talk about some things you already know about, and that's okay. We're going to get through a fair amount of material in the next 30 minutes. And as Alexis said, please feel free to put your questions in the Q&A. We won't pause during the presentation because we do want to make sure that we have time for our second speaker. And then we'll have time at the end for questions. So first of all, you want to think about batteries really as something similar to a generator, right? You're providing backup power to your home. There are other uses which we'll talk about, but providing backup power to your home similar to a generator, except the fuel source is the sun, which is really great. We're primarily talking here about battery backup for grid-tied homes, not for off-grid systems. So if you're thinking or looking into putting battery and solar together for a system that doesn't have utility service, that also is great. It's sized and designed very differently because it has to cover all that electricity usage. But the technologies you're seeing here are also going to be very similar for that arrangement. So some reasons why you might be interested in batteries. Really what you're thinking about here is primarily for folks who are experiencing frequent utility outages, or perhaps if they have some critical needs in the home. This is also really important. Certain parts of the country where we do our co-ops and other places, we have a lot of interest around disaster preparedness. In Florida, in Texas, there's a lot of interest there as well. And then this advanced utility rates slide or mention here, this is for places that don't have net metering, and other arrangements where batteries might actually help you save more money and maximize more of that electricity cost using the battery for alternate purposes. So we might talk about at the end, just want to bring that up. Some of the disadvantages, batteries are still pretty expensive. Those costs are coming down every year, which is great. But in some cases, you might find that it actually is still more expensive than the cost of the generator, a fossil fuel generator. So we do want to just point that out. If you're looking at backup solutions, you may want to consider that as well, just to make sure you understand what the trade-offs are there. Also, just to think a little bit about, even though we're talking about battery backup here for resiliency, the main idea here is that there actually is a cost to that resiliency, right? If anybody has ever lost power for an extended period of time, you know that there's costs associated with that. So we don't want to discount those. They're harder to calculate, but if you've been in that situation, you know that it is not free to not have power for several days or even longer. So we do want to just point that out. And the great idea of pairing solar and batteries together is that fuel source, the solar on your roof or somewhere on your property, is actually fueling those batteries for long-term continual use when sized appropriately, even in an outage. Just kind of reinforcing that point here, the sun's the fuel, the battery is the storage that's holding that energy, and then you're powering important loads throughout the house that you're going to be running. You may not be able to power all those loads. We'll talk about that in a little bit, but you will be able to power at least some of those critical loads depending on your budget, what kind of energy usage you have, and also other things like your space constraints and things of that nature. So we'll come back to that point in a minute. The general idea though here is that those panels on your roof, in the event of an outage, they're supplying that solar to your battery through an inverter. There are a couple different configurations there, which we're going to talk about later in the presentation. And then at night, in that outage, the battery is powering some or all of the loads in your house. And then the next day, the solar comes back on, recharges that battery, and keeps it topped off while it's powering things in your home as well. So that is really the simple and basic setup for solar plus storage and how that works in an outage. Important home loads you want to be thinking about, just like a generator, when the power goes out, those batteries kick in. There's no need to flip switches or anything. The power just comes on instantaneously. And it's actually a really smooth transition when that's configured. There's something they call an automatic transfer switch that's going to isolate your house from the grid in the event of that outage and allow those batteries to power some or all of your loads. Thinking about some of those loads, they're going to be, again, things that are important to you when the power is out. It might be an air conditioner, like a window unit, for example. It might be lights or your internet connection, or anything that is important to you that you would want to make sure to continue to operate. With that in mind, though, because the batteries are still a little bit expensive, you're not necessarily going to be able to back up all of those loads. And this is going to vary by location, right? If you're in Florida or in Texas or Arizona, where you have a lot of cooling loads, for example, you may not be able to run your whole house air conditioning unit on batteries, right? That's going to take a lot of batteries to cover that. If you have the budget to do that and you're willing to, we certainly see homeowners do that. But generally speaking, when you're going into thinking about solar and batteries together, your conversation with your installer should be talking about what you want to back up, why you want to back that load up, and then being able to identify all those loads to be sized to be connected to the storage so that they'll still run when that transfer switch goes off, when the power goes out, and you can still use them. That is what you're looking at here is just an example of what that looks like. Physically, that's the installer coming and relocating some circuits in your home to that critical load panel or that backup panel, and then connecting that backup panel not only to your main circuit or your main panel so that it runs when there's grid power, but also connecting it electrically to your backup system, your battery system, so that it can feed that set of circuits when the power is out. So those are some things to be thinking about when you are thinking about how big of a system you want to, or how big of a system you want to buy and what you really want to back up. I know I've repeated this a couple of times, but it's really important. One of the things that we see when homeowners are talking to installers is just making sure those expectations are set appropriately. Installers will be doing this with you as well when they're talking to you, but it's really helpful for folks to go into that conversation knowing I might have a limited budget. I might not be able to back everything up, but I do know that I want to do some things. So questions to ask about before adopting storage. As I mentioned, like, what do you need to power? So that's not only the like how much energy you're using, but also like how much power. And we'll get to some examples of that in a minute, some definitions, and also for how long. Your scenarios of backup might vary based on where you are geographically. If you're someplace where your heaviest electric loads are in the wintertime, for example, your system design might be different, because you're going to have less solar resource potentially available to charge that battery than if most of your loads and requirements are in the summertime, when maybe you have more sun to be able to charge those batteries up. So those all factor into that design for an installer to make sure that they've got the right system for you, and that it's also fits into your budget. I'm going to step 2 steps back here and talk about some basic terminology just to make sure everybody's on the same page here, because these terms often get interchanged, but they are very different, and they are different in the context of backing up your battery system. So when I'm talking about power, I'm referring to what we think of as instantaneous wattage, right? So it's going to be how much is in any given moment, what power you have from a battery system to actually run a load in your house. Versus energy, which is really thinking about like for how long. And that is over time, how many things can you run and for what time period can you run them based on how much power they're drawing over a time period. So power and energy are different. Power is kilowatts, energy is kilowatt hours. Just to give you a visual of that, you can think of kilowatt hours as the thing that is stored in your battery. So the batteries that you'll see on the market, they're going to be rated in kilowatt hours. For example, like a common lithium ion battery pack that you might buy might be 10 kilowatt hours versus power, which is that rating of how much power can flow through the battery at any given moment. And the reason that is important and why that's a little different is because the electricity loads that you have don't all use the same amount of power at any given point. Just to give you some more visuals here, your air conditioner is going to be drawing a lot of power at the one time. That is like a giant flow of water, coming out of a fire hose, versus a little bird chirping and drinking a little bit of water in the water fountain for, say, a cell phone charger. That matters based on the type of system you have and how much it can support for instantaneous power. Because of that, there are some loads that are challenging to back up. I mentioned earlier, but central air conditioning uses a lot of power at once. Electric ranges, for example, especially the resistive heat ranges that have typically been out there. Water heaters, dryers, anything that is like using resistive heating for its purpose is going to draw a lot of power at once. That's high wattage and high amps. There's also some loads in your house that when they start, draw more power when they first get started, and then draw less. So that's also part of that calculation, or that idea of how much you want to be able to run at once. And there are solutions for that. As you can see here, obviously more efficient appliances, being able to only use certain things at certain times. So you might find if you have a critical loads subpanel, for example, that only supports some circuits, you might only run, one of the high load things at once. You might run the air conditioner all day, but then in a grid outage, you might turn it off and then, run your stove, for example, if you're trying to do that. Or potentially installing more capacity. Like I mentioned, batteries, still not, the prices are coming down, but they're still, reasonably expensive. So you're going to have to decide whether you want to install a lot of batteries to cover more of your loads and have more convenience for more cost, or whether you want to size it down and only cover stuff that really matters. Just to give you some comparisons here in terms of, energy and what you're storing, that capacity really determines how many things you can run over some period of time. So if you look here, just average, this is nationwide, so it's going to vary by region, but average home is using 20 to 40 kilowatt hours a day. So that's going to be something that some of that amount you're going to need to be able to cover from your battery system while the solar is charging it, and then be able to run that overnight so that the next day, if the power is still out, the solar can then run loads in your house and be able to charge that battery back up again. And that's part of what the installer will help you with, is sizing that system. So your solar array is the right size to be able to charge those batteries in the event of an outage and be able to supply enough fuel, enough solar fuel to the system to keep it operating. Some examples here of this. This is a, a fictional example, but, a single lithium ion pack of, 10 kilowatt hours, you might run a couple of these things in this configuration: a refrigerator, a microwave, maybe a washing machine, maybe a window unit. But again, that stove, that dryer, that central air conditioning unit is, those are going to be challenging to run with such a small system. Some other considerations to think about when you're thinking about solar and storage. One is the space, not only for the solar panels, those might be on your roof or they might be on the ground, but also for the batteries themselves. They're probably going to be indoors. They can be outdoors in some situations if they're, in the shade and in fair conditions, but you're going to need to identify where those are going to go. So there's a physical, piece of this, of talking with the installer about where this is going to go. Two, there's obviously some cost considerations there in terms of the size, and we've talked about that a little bit. Those additional components like that sub panel, the battery unit itself, is sometimes, depending on the solution, sometimes it's a battery unit plus an inverter that get combined. Other times it's a single battery unit that has that inverter inside, and that when I say inverter, I mean that's converting that DC electricity that comes out of the battery into AC electricity, which is what your house uses. Solar panels are also generating DC electricity and getting converted to AC electricity for your household. So there's some conversions happening there. And again, we'll talk about some of the differences a little bit later, but that requires extra components for the battery system. And then the sizing of the system itself for solar, like I mentioned earlier, you want to make sure it's sufficient to be able to keep those batteries charged. Quick pause here. Just I will probably, if they haven't put it in there yet, I'm sure they will, is our storage guide. Has a lot of these topics if you really want to read through them in more detail. We just refreshed it and redesigned it this year. So please check that out. It's a really great resource, and we encourage you to take a look through that if you want to read more into these topics as well. So let's talk a little bit about battery integration. Looks like we're doing well on time. It's excellent. First, you've heard me talk about lithium ion batteries. I just want to sort of call out, like, historically, the battery market has really been dominated by lead acid batteries, sealed lead acid in particular for battery backup, although there are other types. But in the last few years, as the costs have come down for lithium ion production, which has been driven in part, frankly, by a lot by EV manufacturing, because those batteries that are going into those electric vehicles are very similar or sometimes even the same components that are being used in home battery backup storage. So that's driven the price down, which is excellent, and that will continue to happen. But as a result, really, when we're talking about battery backup for homes, in almost every case now, we are talking about lithium ion storage. So we are just going to focus on that technology. You can see some of the pros listed here. It's a higher density than lead acid batteries. It has a longer lifespan of operation, and it also is able to cycle more often. And when I say cycle, I mean discharge, recharge, discharge, and recharge. That is a significant advantage over the old lead acid batteries, which had fewer cycles in them before you needed to replace them. And then also the idea of modularity, being able to add pieces on relatively easily. And that'll vary by manufacturer, but generally speaking, there's some good options there to be able to do that. There are other chemistries. Every time we do this, we certainly get references to different types of chemistries that are not lithium ion. I hope that those chemistries become commercially viable and continue to drive the price down in the future. But right now, the giant elephant in the room is lithium ion. There are a couple different flavors of that. For folks that have followed this a little more closely, you'll notice that there are lithium ion batteries that are, for example, use nickel, manganese, cobalt oxide. Those have typically been cheaper in the past and have been used in a lot of applications, including home battery backup. But we're starting to see a pretty consistent trend towards lithium iron phosphate, which was more expensive and still is, but those prices are coming down, which tends to be a more stable chemistry of lithium ion in terms of the potential for fires and things of that nature. That's not particularly common with home battery backup systems because there is a management system associated with it that makes sure that that doesn't happen. But lithium iron phosphate batteries are definitely becoming more and more prevalent in the market, and probably will continue to do so because of that over time. There we go. Next, operations and maintenance. You heard me mention this earlier, but this idea of the lithium ion battery units, you can see some Tesla ones here. We've tried to sprinkle different products and manufacturers in, so there's some variety, which you'll see. But they're usually going to be wall mounted, sometimes floor mounted, and they need space or clearance around the batteries to be able to ensure that you've got proper airflow for them. And those are going to be installed according to manufacturer specifications. The installer will do that. But correspondingly, where you put them matters for that purpose, right? You can't just sort of like shoehorn it into a space. There needs to be room around it, which means it might not go where you think it will go. And that's something to talk about with your installer about where. And then this last point here about flooding, I hate to mention this because it's obviously a sad fact, but if you're installing battery backup system and you are in a place that is prone to flooding, it's really important to talk about where that's going to go. If you have some choice in the matter and you have experienced flooding in the past, or you are in a neighborhood that may, potentially putting it up higher out of the way can be a way to mitigate some of that risk, so that if your property floods, that battery is not going to be submerged and damage it, or potentially even cause a fire because of that, depending on the chemistry. So just talk to your installer about that. It may not be a thing for you, but because we've seen this happen, unfortunately, recently, especially in Florida with some of the hurricanes, we just want to make sure we include that and mention that as another discussion point, if that is something that is applicable for you. A little bit more about the siting considerations. Batteries, as you might imagine, function much better when they are not too hot or too cold. They do have a pretty wide temperature range, as you can see here. Lithium ions in particular, that's an improvement over lead acid batteries. They're usually going to be installed indoors, but in places that have reasonably stable temperature fluctuations, they might be outdoors. Generally, you don't want them in the sun. The less fluctuation in their temperature, the more likely they're going to operate for a longer period of time. Okay, so let's get to some of the wonky pieces here that I mentioned earlier real quick. I mentioned a little bit about DC conversion to AC. There are a couple different ways that batteries can be configured. DC coupled means that the battery is, it's DC battery, so it's producing DC electricity, is on the same, essentially is connected to the same inverter or on the same side as your solar panels. So it's much more efficient. It's not converting it back and forth. The solar power and the DC and the battery power are essentially flowing into the same place without having to flip it to, to AC power until you are supplying the home with power. AC coupled, which often happens when you're installing batteries after solar, is when the battery system, so that would be a battery unit and an inverter, is connected to your solar through your home electric system. And the solar also has an inverter. So you're essentially, if your solar is charging your batteries in that system, you are converting it from DC to AC, and then AC back to DC to charge the batteries, and vice versa. So AC coupled is certainly a way to solve some problems for retrofitting battery storage. Generally speaking, though, if you can put it as DC coupled, that tends to be the better solution. But we do want to make sure that folks know that there are multiple options there. I will point out as well that if you have certain time subsystems, like a microinverter system, for example, with Enphase, that those are going to be AC coupled, but they're done in a way that it's integrated, and there's actually intelligence between the batteries and the microinverters, which provides some efficiencies and some benefits from that. Some other considerations, this is sort of our catch-all slide, but it's important when you're thinking about purchasing. One is insurance, thinking through that. Also the documentation, I'll point out a couple things here. When your system is registered, is making sure that you've got proof of ownership, that you've got whatever information you need to be able to get that system registered for the warranty, and also who's doing it, whether you're doing it or the installer is. as well as some of the requirements for connectivity around the battery unit. It might, for example, need to have an internet connection. So just want to make sure you understand those things, and that is, you don't have any surprises along the way. Economics. So let's get to a little bit of the cost. Storage is going to be priced with a couple pieces here. One is the hardware. That's the biggest, the biggest piece of this, and that's the battery and the inverters and all the pieces we've talked about. Next is installation, assembling it on your property, making sure that it's functioning. Excuse me. And then last are those lifetime maintenance requirements, potentially replacing parts, which should be minimal for those 10 years, but it is a good idea to potentially have it checked out periodically to make sure it's functioning. Retrofitting, I talked about this a minute ago, but there are some, when you're doing it with solar upfront, immediately, you're essentially reducing some of the challenge of retrofitting your solar array later for batteries. But you can do it later and be able to take advantage potentially of some savings with the battery prices as they continue to fall. You might either be swapping out your solar inverter to enable DC coupling at that point, or installing an AC coupled system, as I mentioned, with the ability to connect your battery and its inverter to your house, and have the solar and its inverter be operating separately. So both of those are options. There's a lot of technical details there I'm glossing over that you'll want to talk with your installer, but just want to point out that the installing batteries later is possible. There are some really great news with respect to incentives. Now, with the passing of the Inflation Reduction Act, the storage that used to be 30% only when it was coupled with solar and 100% charged by solar is no longer an issue. So you can install batteries without solar, with solar, you're still going to get that 30% tax credit all the way through until 2032, where it steps down. So that is really great news. We're seeing states also include incentives for storage, as well as some utilities. If you're looking at those state, excuse me, and utility options, just make sure you understand what those requirements are. They'll often be a requirement for them to be able to use your battery, which is not necessarily bad, but just understanding how that interplays with your need to use it as backup power. I know that was super speedy, but I am very happy to say that we covered that information, and we're going to have time for questions. And right now, I'm going to turn it over to Alexis to introduce our battery owner to share some of his experiences, and then we'll jump into Q&A.
Thank you so much, Corey. We're so excited to be joined by Eric Jackson, who's going to talk to us specifically about his experience as a solar and battery homeowner in Florida. So with that, Eric, I'll turn it over to you.
Thanks, Alexis. Can you hear me? Am I good?
Yep, you're good.
Okay. I live in Estero, Florida, and I installed my solar and batteries about 3 years ago. I have a 40.5 kilowatt hour battery. The interesting thing was, with all the incentives that I got, which were the tax credit, and then I got a little reduction in the original price, and I negotiated because I told them I pay them cash. So the bottom line was the 40.5 kilowatt hour battery cost me roughly around $15,000. That's a lot cheaper than a generator, because now generators are going at around $25,000. So it was a really good deal. And I run my whole house on it. Everything, my car, my air conditioning, and the air conditioning is usually on 24/7. So when we had a hurricane here, an Ian last year, we had we had an outage. Some people had an outage for almost 2 months, I think Cape Coral and some other areas. But our outage happened for over 2 days. And I was looking at my notes, and last year we had 23 outages. And some of them were only for 5 minutes or 10 minutes, some maybe for a couple of hours. But when Hurricane Ian hit, when we were the few people that had batteries. So when we go outside, you hear all the generators and the gas generators are smelly, stinky, and extremely noisy. And then the propane ones were very noisy also. But what happened was, when the energy went out, our neighbors knocked on the door and they said to us, you still have power? I says, yeah, sure, we have power. So they came in, we made them dinner, we made breakfast. A lot of the neighbors came over and we watched the storm together because we were in the eye wall. We were 18 miles away from the eye. And so we experienced 140 mile per hour winds, but the solar panels stayed intact. And as soon as the power went out, we didn't even know it because, like Corey says, it was instantaneous. So we didn't tell. And then we never ran out because the sun, it was always replenishing the batteries. So we went really well. So that was basically one of the best investments we made, because now we're energy independent. We get very, very little energy from the grid. They gave us last year, they gave us around 300 or 400 kilowatt hours, and we gave them close to 4,000. So, and my system is a 12 kilowatt system. We have LGs, and they were a little pricier than most. But basically, the nice thing about using it for our whole energy day and night is we double our utilization of our solar generation. So that's, and then also we lower our carbon footprint. So basically we think that we're energy independent, and we love it. And our batteries are inside our garage right next to our car. And we have the option of adding more, but right now we don't need to because it gives us everything we want. So that's my story.
Thank you for sharing, Eric. Appreciate it. And love to hear you being able to help your neighbors throughout the storm with your battery storage. So that's amazing. We'll jump into some questions. Again, please drop your questions that you have into the Q&A, not into the chat. We'll just save the chat for conversation with other attendees and any other comments and thoughts you have. I have seen some folks dropping resources for each other, so that's great. Feel free to continue that. But for questions that you have, put them into the Q&A. And just another reminder that because we have a lot of people on this webinar, we're wanting to make sure we're answering questions that are able to benefit everyone who's on here. So we won't dive into specific questions about your system, but try to keep it more broad. If you do have specific questions, you can feel free to reach out to us afterwards. We'll drop our email into the chat again, but it's helpdesk@solarunitedneighbors.org. And with that, I'll hop into our questions. Corey, are you ready?
I am.
Awesome. Larry asked about this, and I know Eric just spoke to this point too, but I'd love to hear your thoughts. He said, if I add a battery, will that eliminate the blinks when the power grid drops? My generator has a 20-second delay, and so it resets the clocks and computer drops, etc.
I can't guarantee that it will prevent your electric equipment from resetting. It kind of depends on the sensitivity of that equipment, but the flip over is instantaneous, like, a second at the most, probably milliseconds. I have heard folks, sometimes a particular piece of equipment might reset, but that's not necessarily going to always be the case, and it is fairly quick to flip over.
Yeah, I never had any problems resetting. And we've had this for 3 years. Like I said, we had 23 outages, and there's no resetting because it's so quick. It doesn't have time to react.
Great.
The power of electric components.
Thank you both. Robert asked, how do we protect our solar arrays, inverters, and battery storage and electrical systems from a solar flare or from electromagnetic particle event?
We get these types of questions a lot. I don't think that there's a particular way to do that broadly, but those events are also very, very, very uncommon. So I don't think it's something necessarily to be overly concerned about. If you have specific questions about components and how they would handle that, I would direct those to your installer about the particular pieces they're recommending. But generally speaking, that's not an event that I think most people are probably going to be prepared for specifically around these components, just because if those things happen, there will be much broader issues, I think, with the electrical infrastructure. So I would direct those questions to your installer about the specific pieces that you're purchasing, about whether they're compliant with any standards that protect against that.
Thanks, Corey. And there's a couple questions about if you have gas generation still going on your house and kind of how that pairs with battery storage. I'll give you the specific one from Howard, but maybe if you can just speak more broadly to the connection there.
Yep.
Howard said, I have solar and generate more power than we use, but we also have gas generator. Can you speak to the usefulness of battery when you have gas generation?
Yep, that's not uncommon. I think what I would say for folks who are thinking about installing is if you are considering having both of those components, that's totally possible with the right inverter equipment. The generator essentially is the backup to the batteries. So even if you, in that situation, for all the reasons we talked about, solar as fuel, not using the fossil fuel and the smell and the noise, you could probably get most of your backup needs from the battery, and the generator essentially is just there as like a last line of defense versus being the primary means for providing electricity to your home. So we've seen people do that as well, and that's definitely supported with certain equipment as long as you've got the right type.
Great. And then we have a few questions about kind of safety and things like that. Eric, this one I think is more specifically for you from Jeff said, did your battery system get flooded, or were they above the flood level when you had the hurricane come through or other floods that you've had?
Well, we live in a non-flood zone was number one. We're probably 7 miles from the Gulf, but when I decided to get this house, number one, I wanted good southern exposure. I also wanted a non-flood zone. And the electronics, this is what the guys at Tesla told me, because I went to see the factory, is 2 feet. The first 2 feet of the battery, there's no electronics. So you can go almost up to 2 feet without any damage. But our house is graded. So no, we didn't have any issues, but we've done every precaution we can to avoid that flooding. And the other thing was my wife wanted to live on the lake, and I didn't want to live on a lake for that very reason. So we compromised. We live at the end of a pond. So
gotta love a compromise there. And then Elaine also asked as a follow-up to your story. Oh, sorry, Corey, did you have thoughts on that?
Oh, go ahead.
Okay. If you are connected to the grid, which I believe you are, and what your power company is.
Yeah, we're connected to the grid. Like I said, today, let me look at my offset was. Today, my offset was, see, 152%. Whoops. Yeah, 152%.
Awesome.
So yeah, I mean, I am connected to the grid, unfortunately. But then again, my neighbors love me because I supply them with extra. Although, they're only giving me 2 cents a kilowatt hour, and they're charging 16 cents a kilowatt hour to my neighbors. So they're making money on me.
Yeah, that happens. Corey, back on the safety, we have a couple questions. I know you mentioned fire safety, but it looked like there's some more thoughts on, is there considerations between the type of batteries you have and if that affects fire safety, or any thoughts you have with that?
Yeah, and just to sort of reinforce, the fires in a home for home storage systems, very, very rare. Probably more, I don't know the exact percentage, is probably more rare than having another appliance in your home, especially a fossil fueled one, have a problem. But they do make the news with larger installations, so we do feel like it's important for us to mention that. The NMC is the chemistry that I was referring to that has been reported in the past to have what they call thermal runaway, which is essentially when some event happens to the battery, like a physical, crushing or a fire that it's involved with or something else, that the battery essentially has a feedback loop that causes it to catch fire. The chemistry that is not prone to that is the lithium iron phosphate chemistry, which is the one I mentioned is becoming more and more common. But just to reinforce, both of those chemistries in the setting of a home where it is in a safe place, in a good environment, and is connected to the equipment that is programmed to manage it, which is what that inverter is doing, this is not a big risk. So I just want to make sure that that's clear. And feel free to, I would definitely recommend, asking your installers and getting their comments on it as well. But this is not something that we see as a big problem for the home battery storage market. It just does get news coverage in other contexts, like larger arrays. larger installations connected to the utility, for example, or in the context of a car, for example, that's in an accident that has a battery pack.
Thanks for clarifying, Corey. Judy asked if you could expand on the use of batteries to stretch daytime sun into 24-hour power. All the marketing seems to be geared towards keeping the lights on during storms and not day-to-day use. Eric, you might also have thoughts, since I know you said you were running on your batteries right now.
Love that question. Go ahead, Eric. Why don't you talk first and I'll follow up.
Okay. I mean, basically, if I had, would she want to know the economics or the feasibility of running it at night? I wasn't too sure of the question. Was it about my economics, why I'm doing it, or because?
It sounds like just on how it works to be able to use it for 24
well, yeah. I mean,
hours.
basically, after your sun goes down, automatically the batteries just start feeding you energy. So it runs my air conditioning, it runs everything, it runs the whole house, the lights, everything. We don't have to worry about because we have 40.5 kilowatt hours of 100% of that, and by the time the end of the night, it might, from 100%, it might go down to 70% or 60%. So we're not even utilizing that much either. Even with and our number one usage is our believe it or not, is the car, which I told you before. Instead of filling my tank up with gasoline, I fill my tank up with gallons of light. But my second one is the air conditioning. But it works fine. It's automatic. It's automatic. I program it in my phone to use it at night. I can just use it as storage if I wanted to. But I like the fact that I'm doubling my or lowering my carbon footprint, and I'm also becoming more energy independent with that.
So this is just to add to that's a really great answer, and I think just to sort of reinforce that the way that your solar power is credited matters in terms of how you're getting what you're doing with your batteries. So if you're in a place where the credit you get for exporting solar from your array is the same as you would pay if you were going to purchase it, then there's not really any economic incentive to using your battery the way that Eric's describing. He heard him mention earlier, he doesn't get a full value when he exports a solar credit. So there's actually some value for him to do as he described. But if you're in a state or in a place where you don't get, or you do get that full credit for export, it's not necessary. However, there are places where that's not true. And a battery in that situation is programmed for what they call self-consumption. And that is essentially what Eric was describing, which is when that solar power is charging it up during the day, it's also, essentially using that battery's energy to fill up, solar power to fill up the battery, so that at night you're moving your energy usage from the grid to the battery. So the battery is supplying you with that energy at nighttime, where you're essentially just held on to some of your solar generation and you're using it later. The reason that's important is because during the daytime, rather than exporting that extra solar power, which you're getting a lower credit for in that situation, you're keeping it and you're using it later. So that is very much dependent on the rules for you and how your solar is credited in your community. But you can think of it as like shifting your solar power generation and using it later in the evening via the battery and its configuration.
Thanks, Corey. Yeah, we did have some questions coming in about like, if I have net metering, what's like, how does this play into that? Or if we don't have that. So that was helpful to have that. Richard, I think, was asking that in Indiana. If you have other questions, let us know. Kind of along those lines, Judith asked, my utility requires I only have panels to cover my electric generation and nothing extra. So if I have battery or storage, will that cause me to need to use electricity from the utility to recharge my batteries?
It shouldn't, as long as your storage is configured to be able to, your solar is configured to be able to charge up your batteries as you're using them. There's no reason why you can't pull electricity from the grid if you need to top off your batteries. But if you're using it for resiliency, you want to be able to have that solar array be able to charge them fully, the batteries charged fully every day. So that's more a question of like, is your system set up to be able to allow the batteries to continually operate in the event of an outage? But yeah, there's no reason why the solar can't be the sole source for charging for you.
You know, what's really cool is that during, say that there's the weather service says, oh, there's a hurricane coming. What the battery will do, it has direct line to the weather service. So what they'll say is if you're not producing enough solar, they will take it from the grid to fill your battery up for preparation for the storm. So
Yeah.
that's a really, really nice safety program that they have with regards to the batteries.
Yeah, that's a really good point. Good luck with your fossil fuel generator magically filling itself with more fuel when the storm is coming, but that's essentially what Eric's describing for the batteries.
Looks like there's been a few questions about how cold affects battery, or if there needs to be like a heater to keep them warm. Is there any like considerations for if you're in a cold climate versus somewhere warm?
Yeah, that's all part of I think the design process with the installer about picking the location for the batteries. There are battery cabinets that have minimum heating to make sure the batteries are okay. Lithium-ion storage units get used in all sorts of harsh conditions, so there are ways to deal with that. But generally speaking, you want to have it someplace where you don't have to add extra cost or extra concern to be able to make sure that it's working. But yeah, those are all manageable situations with the proper design.
Yeah, it is a chemical reaction, so you want to have the optimum window of temperatures, and if it's too cold, yep, it's hard. It has a very difficult time to do the reaction.
Yep, exactly.
Another question on a different note. Do you have any thoughts on insurance implications for having battery storage on your home?
I love that question. That is probably a moving target, I think, for like many of these issues related to insurance. I don't know if the person is asking that from Florida, where we've seen a lot of these challenges with insurance companies. Like we say for solar, call your insurance company ahead of time, let them know that you're installing, make sure that there's no impact to you. It's not only a good thing to just be aware ahead of time, but it's also an opportunity potentially to educate your insurance company about the fact that people want this, and potentially that they need to reinvestigate their policies if they're maybe giving you an answer that's not satisfactory. So always call ahead of time and double check what that means for you and for your insurance provider.
Yeah, I'm on my third insurance company now. You just have to welcome them to the 21st century, because they're still thinking about horse and buggies and typewriters.
Corey, feel free to say we don't want to dive into this can of worms right now, but there is a lot of questions from folks about using EVs as batteries and any guidance around that. Do you have I know that could be a whole webinar in itself, but do you have any thoughts around that we could address?
Yeah, that's tons of excitement around that. Frankly, when I saw the Ford F-150 announcement, I was pretty excited. I live in the city. I have no chance of parallel parking a F-150 in front of my house, but I still love the idea. The short answer is that most cars that are electric vehicles, their warranties are not going to support you doing that. So you really need to make sure that you're not running afoul of your vehicle warranty. I believe it's the Nissan Leaf that does support that with some extra equipment, but that's not something that I follow particularly closely. It is something that will probably become more common. Right now, though, it's still not something that is available and possible with every electric vehicle without potentially voiding your warranty. So I would say make sure you do your homework on that. For folks that are interested in products like the F-150, for example, I'm assuming most folks know what I'm talking about, but for people that don't, the giant batteries that come with this truck are also enabled and specifically set up so that they can be configured with a companion system that's tied to your house that lets you essentially plug your truck into your house to be able to provide that battery backup. And those battery banks in the truck are sizable, so they can actually power your whole home to be able to do that. But that's extra equipment to be able to set that up, and that's relatively early on. That's through a partnership they have with a solar company to be able to do that. But those types of solutions, I think, are becoming they will become more common. Right now, though, it's still pretty early days.
Yeah, and I know I saw a lot of chatter about that, so it's great to see folks sharing different resources and things that they've found. Continue to do that as well. Corey, is there power loss from the batteries as they age, or any considerations for the long-term status for batteries?
Yep, the second law of thermodynamics is definitely in effect here, like it is for the rest of our universe. You will, in fact, lose power for a little bit over time for batteries. They need to be, charged. Lithium-ion batteries are pretty stable for that. They will hold a charge for a long time, but over time they, they do degrade. And their most warranties out in the market right now are 10 years. There are 1 or 2, I think, are probably, or maybe 12. And that's typically like 10 years or a certain number of battery cycles. So it's a good length of time with proper care and minimal usage. You may be able to even get more life out of that, but that is a pretty standard one. Yeah, they do lose charge over time slowly.
Thank you. Carl asked, how is the amount of energy the utility pulls from our battery controlled?
How is the energy pulled by utility? The utility shouldn't be pulling energy from your battery unless you have an arrangement with them to do so. There are programs, especially in areas that have like high solar adoption, California, Hawaii, and some forward-thinking utilities and private arrangements as well, where companies are essentially coordinating solar and storage systems in a diverse area, like multiple homes and multiple businesses. In that situation, a third party could discharge your battery for services to the grid, but that's not the default. If you're installing with solar and batteries for backup power, your utility is not drawing from your battery unless you specifically have an arrangement with them to do so, which is still pretty uncommon.
And then Kirk asked, could you comment on how batteries are recycled, what that looks like?
Yes, actually, we have a link that we'll put into the chat. I'm excited that we prepared some links and they actually, I knew this one would come up. There's the battery recycling, that article does a good job of kind of describing the companies that are trying to solve this problem. There are various ways to do that now. They're still, pretty expensive. And the second life, one of the things that we're, I think, particularly interested in is sort of the second life of batteries, especially electric vehicle batteries, where after, they're no longer able to power a drivetrain, they still have, a fair amount of life in them to potentially be reused. But it is still pretty early on in the recycling industry as far as recycling batteries. So like we say with solar panels, the longer you can keep your unit in service and operating, the more you're contributing to, not having to go through that recycle process. But all the components, or significant amount of the components in a battery are valuable and ideally would be recycled. One of the challenges that they're having right now is that many of those batteries are constructed in a very customized and bespoke way that makes them hard to take back apart. So we probably will see in the future that batteries will be constructed in a way that makes them easier to disassemble. That is not the case right now, which means it's very a very labor intensive and expensive process to do that.
A more general question, Corey, do you have any general suggestions for what to look for when finding a battery installer or supplier, or how to kind of evaluate your options?
Thank you for that question. That's something that we usually put in that slide deck that I'm realizing now with that question is not in there. You're like any contractor, ask how much work they've done in this, check references. Some installers have done a lot of battery installations. Some are still getting their feet wet and understanding, what they need to do in this market. So absolutely appropriate to have them talk about how many installations they've done in what markets. If they've done installations in your area, for example, if you want to make sure that they know how to navigate the permitting process for you, that's important. Another thing that you will see installers do ideally is have a conversation with you about your electric needs and what you want to back up and be able to identify those loads like I talked about. It is really easy to just install a system and expect it to cover it with either a lot of storage, which can be more expensive, or not take the time to do that. But ultimately, an installer should be setting your expectations about what can be backed up with what you're buying, and have an idea from you what you want to be backed up, so that you've got a system that actually works for your needs. Because at the end of the day, when the power is out, you want to make sure that system's functioning. The other thing I'll say is that when you do have your system installed, they should be testing it with you, actually running it through, turning the power off and making sure that you know how it works and that you know what's working and what isn't working. So at the end of that process, that's a really important education step that we see good installers doing to make sure that those expectations are set appropriately for you.
That's a good point, Corey, because I had to have them come back 3 times to do it correctly. I mean, I'm a chemical engineer and we did battery research, but I knew what was going on. So they didn't install it. So it took them over 3 times to do it. That's how they even gave me a refund, a little bit over $2,000 refund because of my troubles, because they didn't install it correctly the first 2 times.
On a completely other note, but we haven't chatted too much about this tonight. Could you speak a little bit to the tax credit, Corey? There are some questions around. The specific question is, if they got the tax credit in a previous year for getting their solar panels, would they be eligible for it for battery? But if you have any other thoughts around the tax credit to share.
The answer is yes. If you install batteries and you've already taken the tax credit for solar, you absolutely can take it for your batteries. Excuse me. And as I mentioned earlier, you don't need to have it paired with solar anymore. So I feel it's a great combination, and we certainly love it for all the reasons we said in this webinar. But if you just have battery system in your home and that's it, it will also qualify.
Great. We love to hear that. I'm checking through our questions to see if we have anything else to wrap us out here. Corey, do you have anything else that you want to address before we end? There are some questions still in here, but we're going through again. Folks will drop our email into the chat for everyone to address any specific cases. You can email our help desk at helpdesk@solarunitedneighbors.org. But Corey, do you have anything you want to say before I wrap us up?
I would say we've obviously shared a lot of information with all of you about batteries, but I have a feeling with 400 people on this webinar that a lot of you have batteries, or maybe know people who do. So I would say if you have a story similar to what Eric shared today and you want to share it with us, we would love to hear from you. It really is helpful for our education work and our advocacy work, for that matter, to be able to highlight the stories of people who actually have solar and storage and how it benefits them. So I don't know, Alexis, if you have a handy link there, but we would love for you to contact us and share your information so that we can raise that up to our network and be able to highlight the fact that you've already invested in improving our electric infrastructure and transitions to renewables in the 21st century. So thank you all for spending time with us this evening and for your interest here. And we hope that you will spread the word. And if anybody has questions, as Alexis said, we are available at our help desk at solarunitedneighbors.org. And we would just really appreciate the time this evening that you spent with us. So thank you.
Yeah, thank you, everyone. Again, we'll also send out the recording of this as well as the resources to the links that were dropped in the chat and all of our contact information. Appreciate the plug from Corey. We'll send a link for how you can easily share your story, as well as I dropped in my email. You can connect with me at getinvolved@solarunitedneighbors.org. We want to give a special thank you to Eric for joining us and sharing his story and being willing to answer questions with us. It was a great night and we appreciate everyone for joining. So thank you all and have a great night.